Hello dear student. Exercise 6.2 we are going to see in the triangle. In the figure 6.17, it is given DE is parallel to BC. This line DE which is parallel to BC. Find EC. In case of first we have to find this one, and in case of second we have to find AD. Now if these two lines are parallel, so based on the basic proportionality theorem, AD by DB equal to AE by EC. Similarly, in this second figure, AD by DB equal to AE by EC. So this theorem is called basic proportionality theorem. So AD by DB equal to AE by EC. So what the value we have to find out? Just we have to take X. So 1.5 divided by 3 equal to 1 by X, because D is parallel to BC. So after doing the calculation, X equal to 2 centimeter. Similarly, in the second figure, AD by DB, AE by EC. So DE is parallel to BC. So this is based on the basic proportionality theorem. X by 7.2 equal to 1.8 divided by 5.4. So X equal to AD equal to 2.4 centimeter after doing the calculation. Now question number 2. E and F are points on the side PQ and PR respectively of the triangle PQR. For each of the following cases, state whether EF is parallel to QR. Now same concept. If two sides are parallel, then definitely this is the, suppose EF is parallel to QR, then we have to see the ratio, what the ratio is given, and if ratios are equal, then this is parallel. So first diagram, it is given PE and EQ, PF and FR. So we will take PE by EQ, PF by ER. PE by EQ is 1.5, 1.3, and PF by FR is equal to 1.5. So this ratio is not equal. This ratio is not equal, so it is not a parallel. Second case, from the given diagram, PE by EQ equal to PE by PF by FR. So we have to see the value after doing the substitution. PE by EQ equal to 8 by 9, PF by FR equal to 8 by 9. So both value are same. So both are lines are parallel. EF is parallel to QR. Now in this case, PE by PQ equal to PF by PR. So PE by PQ and PF by PR we have to take. P by PQ is 9 by 64 and PF by PR is equal to 9 by 64. So both are equal. So both are parallel. So just by substituting the value, we have to check two lines are parallel. Now question number 3. Now question number 3. In the given figure, LM is parallel to CB. This LM is parallel to CB and LN is parallel to CD. So this is parallel, then we can write AM by MB equal to AL by LC and AL by LC equal to AN by ND. So this value we can write. We have to prove AM, this in the triangle ABC, AM by AB. This bigger value and this is the smaller value, AN by AD. We have to prove. Now ACB triangle we will take first. ACB we can write, it is given LM is parallel to CB. So AM, now you can see the diagram. Yeah, now you can see in the triangle ACB, LM is parallel to BC. So this is the given condition. So based on that, AM by MB equal to AL by LC. This is the first. Similarly, LN is parallel to CD. So we can write AL by LC equal to AM by ND. So this is the second condition. So in this first and second, right hand side value, if you will see the ratio, AL by LC both are equal. So definitely AM by MB equal to AN by ND. So from this first and second, we can write this. So AM by MB, we have to take the reciprocal. First of all, we have to take the reciprocal of that. So MB by AM, ND by AN. Now, what is the trick of this question is, because one is smaller, we have to prove the one is smaller and another is AB is in the denominator, which is bigger value. This is the bigger and this is the smaller value. So in this type of question, just we have to see when we reverse this and add one both side. By adding both side, MB plus AM divided by AM equal to ND by AN by AN. So MB plus AM is nothing but AM. And this is AN. AM plus MB equal to AN plus ND. Just reverse again, reciprocal of that. If we will do, then we will get the result AM by AB equal to AN by ND. So from here to here, this step is very, very important. So when we have to add and when we have to subtract, this is the very important case. In the coming question, we will see how to find out the value when we will use the subtraction. So here, first step is we have to do the reciprocal, just see what is required. So based on that, we have to do the reciprocal of the term. After that, just add, and after adding, we are getting the one full length of AM plus MB is nothing but AB. That's why we have to add. So this is the trick of this question. Now question number 4, in the given figure, DE is parallel to AC. It is given, and DF is parallel to AE. So according to the Thales theorem, now we have to prove BF, this part divided by FE, this equal to BE divided by EC. So first of all, we have to take a triangle BAE. In this triangle BAE, DF is parallel to AE. This line and this line both are parallel. So we can write BD by DA is equal to BD by DA is equal to BF by FE. So according to this, whatever this line is parallel to this line, so based on Thales theorem, we had written. Now next condition is given, DE is parallel to AC. So DE, this is DE, this is DE is parallel to AC. So if this is parallel, then we can write BD by DA equal to BE by EC. So this is theorem 2. So from first and second, we see this value is equal. Left hand side value is equal. So from first and second, we can write right hand side, that is DF by FE equal to BE by EC. So this is the value. Now question number 5. In the given figure, given DE is parallel to DE, this value DE is parallel to OQ, and DF is parallel to OR. This, if this is parallel, then we can take POQ. This triangle we will take. So ED is parallel, DE is parallel to OQ. So based on that, we can write PD by DO equal to PE by EQ. This is the first. This is the Thales theorem. Same way, we can take the triangle POR. In this, DF is parallel to OR. This value DF is parallel to OR. If this is parallel, then we can write PD by DO equal to PF by FR. So this is, so from first and second, this is the Thal's theorem. So from first and second, what we can write, left hand sides are equal. So PD by DO, here the value left hand side PD by DO, and here also the value PD by DO. This value are same. So right hand side PE by EQ and PF by FR, both are same from first and second. So if we will see this ratio, then this is the ratio in the triangle PQR. PQR and PE by EQ equal to PF by FR, then definitely EF is parallel to QR, because this is the ratio PE by EQ equal to PF by FR. So based on that, we can write EF is parallel to QR. This is the reverse of the Thal's theorem. So this is the value, this is the converge of the Thal's theorem. Now question number 6. Now question number 6 is same as we solved the question number 5. So PQ, this PQ line is parallel to AB and PR is parallel to AC. This is the two value is given. Now we have to prove QR. This is the QR which is parallel to BC, that we have to prove. Now from the triangle OAB, if we will see triangle OAB, then PQ is parallel to AB. So we can write here OP by PA equal to OQ by QB. This is from the Thal's theorem first equation. Similarly, we can write in the triangle AOC, PR is parallel to AC. PR is parallel to AC. So based on that, we can write OP by PA equal to OR by RC. This is the second. So left hand side value are same. So right hand side OQ by QB. See, OQ by QB equal to OR by RC. So based on that, we can say that QR lies on this triangle of the sides OB and OC. So QR is parallel to BC. This is the reverse of the Thal's theorem. So from the first and second, OQ by QB equal to OR by RC. So this is the triangle. So in the triangle OBC, Q and R are the point on OB and OC respectively. So we can write OQ by QB equal to OR by RC. So by converge of the Thal's theorem, we can say this is parallel. Now, question number 7. Now, question number 7, using theorem 6.1, prove that line drawn through the midpoint of one side of a triangle. Line drawn through the midpoint of one side of a triangle. This is the triangle parallel to another side bisects the third side. So in the triangle ABC, in which D is nothing but the midpoint of AB, D is nothing but the midpoint of AB, where we can say AD by DB equal to 1. Now line L drawn through the D such that L is parallel to, this line is parallel to BC and meet the AC at the E. So by basic proportionality theorem, we can say AD by DB equal to AE by EC. This is the theorem. So AE by EC is also 1 because this is nothing but the midpoint. So AE by EC equal to 1. So from the equation first, because AD by DB equal to 1, so AE by EC is equal to 1. So E is the midpoint of AC. E is the midpoint of AC. So line drawn through the midpoint of one side of a triangle. Line drawn through the midpoint of one side of a triangle is parallel to another side bisects the third side. So in this way, we can prove. Using theorem A6.2, prove that line joining the midpoint of any two sides of a triangle. Midpoint, this is the midpoint of any two sides of a triangle is parallel to the third side. This is parallel to the third side. So consider the triangle ABC in which D and E are the midpoint of AB and AC respectively. Now AD by DB equal to 1 and AE by EC equal to 1. So based on that, we can write this D and E is, so AD by DB equal to AE by EC we can write, because D and E are the midpoint. So AD by DB equal to AE by EC. So definitely we can say that this is nothing but the AD and BC are parallel. So by converse of basic proportionality theorem, line joining the midpoint of any two sides of a triangle is parallel to the third side. Now, question number 9. ABCD, a trapezium in which AB is parallel to DC. AB is parallel to DC and its diagonal intersect at the point O. We have to prove that AO by BO, this value AO by BO equal to CO by DO. Now ABCD is a trapezium in which AB is parallel to CD. This AB is parallel to CD, it is given. And diagonal AC and BD intersect each other at the point O. Now we have to prove this value. Now we have to do one construction, draw EOF. EOF we drawn, which is parallel to AB and parallel to CD. Now, once we will take this, do this construction, after that, in the triangle ACD, if you will see the triangle A, C, and D, this triangle ACD, this is the triangle. OE is parallel to DC, we can say OE is parallel to CD. So based on that, we can write AE, this value AE divided by ED equal to AO divided by OC. This is the first. So basic proportionality theorem. Similarly, we can take ABD. This is the value AB and D, in which EO is parallel to AB. So based on that, we can write ED by AE equal to OD by OB. This is the second. So if we will reverse this value, then just we can see left hand side both the value are same. So just we reverse this value and write AE by ED equal to, this will go OB by OD. So OB by OD and OA by OC. So from the first and second, if we will see, this both the value are same. OA by OC equal to OB by OD. So we can write whatever the value we have to prove. So OA by BO equal to CO by DO. This is the value that we have to prove. Now, last question, question number 10th, we will see. The diagonal of quadrilateral ABCD intersect each other at the point O such that AO by BO equal to CO by DO. Then we have to prove ABCD is a trapezium. Now, first of all, we see the diagram. ABCD is a quadrilateral. ABCD is a quadrilateral. So its diagonal AC and BD intersect each other at the point O such that AO, this is given AO by BO, this value is equal to CO by DO, this value. So just what we can do, in the same line we can take the ratio, that is AO by CO we will do equal to DO by DO. This is the first value that we can write. Now ABCD is a trapezium that we have to prove. Now from the construction part, through the O we draw a parallel line OE which is parallel to the AB and meet the AD at the point E. Now in the triangle DAB, if you will see in the triangle DAB, EO is parallel to AB. So based on that, we can write DE divided by EA equal to DO divided by OB. So we can write AE divided by ED. This value we can just interchange this value. We can write AE divided by ED equal to BO divided by OD. This is the second equation. Why we are interchanging like that? Reason is from the first, if you will see, BO by OD is the value in the first. So here we have to just do the reciprocal of the term. So based on that, BO by DO and right hand side value is same. So we can write AO by CO, AE by AD. This we can write. So from first and second, we can write AO by CO equal to AE by AD. And if you will compare this, AO by CO, this is AO, this value AO by CO equal to AE, this value AE by ED. That means we can say that this line OE is parallel to DC also. This is parallel to DC also. So in the trapezium, we know if BA is BA, this value is parallel to EO and EO is parallel to CD. Then definitely we can say AB is parallel to CD. AB is parallel to CD, and this is the case where we can say that if two lines are parallel, and same way OE is parallel to CD, since lines are parallel to the same line are also parallel to the other line, so definitely this structure is called a trapezium. So this is the way. Some important tricks are also there, just you have to follow and prove that. Thank you.